So we're going to take a look at your first handout for rate questions, part 2. So the first thing that you want to be able to do is you want to take a look at your handout. So if we take a look at this, we've got this whole thing sitting in here. Oops. There we go. And you've got your first question. So the first question is application of rates and this calculator active. So what I'd like you to do right now is I'd like you to pause me and I'd like you to time yourself for 15 minutes and do this question. Pause now. Okay, so it should be like 15 minutes later for you. And what I'm going to be doing is I'm going to be going through this question to make sure that you know what you're doing here. So it says water is pumped into an underground tank at a constant rate of 5 gallons per minute. So in my rate is 5 gallons per minute. Water leaks out of the tank at the rate of e to the cube root of t minus 5 gallons per minute. Remember, I talked about how the rate is really important for us to sort of look at when we're dealing with these. And it goes from 0 to 17 minutes. At time t equals 0, the tank contains 10 gallons of water. Okay, so that's important. Remember, that's our initial condition. So for part A, it says how many gallons of water leak out of the tank. So that's important that you're reading, right? Leak out of the tank from time t equals 0 to time t equals 3 minutes. So to be able to do that, if we're looking for gallons, we have to integrate our gallons per minute going out. So I would go integral from 0 to 3 of e to the power of cube root of t minus 5 and then dt. I picked cube root for this one because sometimes the cube root is hard to find in your graphing calculator. So you could either go into the math menu where you can find your cube root, or if you just want to have a versatile thing, remember that the cube root is to the power of bracket 1/3. So we can do that as well. So that is something that you grab on your graphing calculator. Oh, my batteries are still low, so that's fun. So if we take a look at this one here, and we're going to get e to the power of the cube root of t minus 5, so x minus 5 to the power of 1/3. And we're going to integrate it from 0 to 3. Now, while my calculator is working on this, I'm already thinking about that next question. Okay, so this is a strategy that you can use for your AP exam. Oh, my calculator is ready. So I'm going to integrate that, and it's going to tell me that I'm going to get 0.6699, so 0.670 gallons. Okay. That doesn't make any sense. Oh, yeah. Okay. Never mind. I'm losing my mind, obviously. This is the out part. I was looking at the in part. Never mind. So, okay, we're at B. How many gallons of water are in the tank at time equals 3 minutes? So to be able to be in the tank, we need to be able to figure out the amount of water that you're actually dealing with. So the amount of water that you're dealing with at 3 minutes would be the integral from 0 to 3 of the in part minus the out part dt, and then plus your 10 gallons of water that you started off with. So we're going to go the integral from 0 to 3 of 5 minus e to the power of cube root of t minus 5, and then dt, and then plus 10. And again, this is a calculator activity. Get your calculator set up to do this work. And then you're going to move on. While your calculator is thinking, you're going to move on to that next question, okay? Write an expression for A of t, the total number of gallons of water in the tank at time t. So you've already really done that in part B. So A of t for this one would be the integral from 0 to t of your in value minus your out value, cube root of t minus 5, and then dt, and then plus 10. So that's going to be your C part. Excuse me. My calculator is ready to integrate now, so it's doing its thing. Well, maybe it's not ready to integrate. Okay, so for part D, it says at what time between 0 and 17 is the amount of water in the tank a maximum? So we're doing a maximizing question here. So if I wanted to maximize or minimize, oh, wait a second, I've got a number to put in here, 14.330 gallons. If I'm going to do an optimization question, remember that we're going to find a prime of t and we're going to set it equal to 0. So when we take the derivative of the integral, this part here is my a prime of t, 5 minus e to the cube root of t minus 5 equals to 0, because of course the derivative of 10 is also going to be 0. So we're going to take this graph and we are going to find the x-intercept of this function that we're dealing with. And hopefully your calculator will help you to do that. In the 10 by 10 window, it's a little bit tight, so I actually moved my right bound, my x max to be 15 so that I could see this. And I'm going to calculate zeros for this one. So we're going to do our first derivative test at this point right here to make sure that we've got all the steps showing for the AP exam that we're dealing with. So left bound and then right bound, and then I'm going to guess something and I'm going to get a t value from my graphing calculator to get 9.1689116. Maybe it might be a good idea to store it. Excuse me again. And we're going to set up our first derivative test. Justify my answer. So when we take a look at the graph, we're going from 0 to 17. You found that this is the 9.168 something, something, something. And you can also see, if you graphed it to find your integral, you can also see that it's above the x-axis here and below the x-axis here. So you can get yourself your nice little first derivative test really quickly. So it says, at what time is the amount of water in the tank a maximum? Justify your answer. The answer would be at t is equal to 9.169 because, sorry, a prime changes from positive to negative there. Okay, so that's D. Now we're going to go on to E and F. Now this is longer than your typical AP exam. It probably would have only had like 4 options here, but I figured we should cover all of them just in case. So we've got E. What is the minimum amount of water? Justify your answer. So in case they ask you instead for the minimum amount of water, you can see that the minimum would happen at either t is equal to 0 or t is equal to 17. So what we would have to do is we would have to find my amount in gallons at 0, which was 10 gallons, and my amount at 17, which is again going to be an integral that I'm going to be dealing with. Oh, I think I forgot to add the 10 for that one way back. So I'm going to integrate, I'm going to calculate my integral right here from 0 to 17. My window is apparently not big enough because it didn't put 17 in. So I'm going to calculate my integral from 0 to 17 now that I've changed my window. That's a 17, by the way. It looks kind of like my A. And it's going to go from 0 to 17. And then, of course, the plus 10, right? So again, while my calculator is calculating, I'm already sort of proofreading this part F. Set up an integral equation that you could solve to figure out when the tank will become empty. Okay. So for that one, I can totally do that one because that doesn't require a calculator. Oh, I'm back here again. So the value that I got for the integral part is 10.692526. So this would be 20.6925 gallons. So therefore it happens, it says, what is the minimum amount of water? So that means that the minimum amount is 10 gallons. And that is because if it says justify your answer, that is because A of 0 is less than A at 17. This is your justify. So finally, for part F, when we take a look, set up an integral equation that you could solve to figure out when the tank will become empty. So the amount, what you want, is equal to 0. You want that to be 0. So essentially, the integral from 0 to t of 5 minus e to the power of cube root of t minus 5, that's minus 5 in there, dt plus 10 is equal to 0. Or you could put the 10 on the other side and you could say equal to negative 10. Okay. That's the first one. All right, now we are on to question number 2. So at this time, again, you're going to pause. You're going to pause me, and you're going to go for 15 minutes, and you're going to give this one a try. So pause me. And then I'm back. So as a pot of tea cools, the temperature of the tea is modeled by a differentiable function for 0 to 10. So it's got this chart sitting up in here where T is measured in minutes, temperature is measured in degrees Celsius. And these are actually values of H of T, not H prime of T. Use the data in the table to approximate the rate. Rate is derivative, right? At which the temperature of the T is changing at time T equals to 8. So what we're trying to do is we're trying to find H prime of 8. But if you look at the data in the table, 8 is not one of the numbers that it's actually in there, which means that we're looking for the symmetric difference quotient. So if 8 is here, the only number that I could really use above it is 12, which means that it's 4 spaces away. I'd have to go 4 spaces away to use these two pieces of data. So that would mean that it would be my temperature at 12 minus my temperature at 4 over 12 minus 4. And that's going to be 42 minus 62 over 8, which is negative 20 over 8, or negative 10. I guess that's negative 5 over 2. So negative 2.5. And my units would be degrees Celsius per minute. So it is cooling, right? Well, I guess we already knew that. It says cooling. Using correct units, explain the meaning of the integral, 1 over 12 times the integral from 0 to 12 of h of t dt. This would create the average temperature of the t from t equals to 0 to t equals to 12 minutes. We are going to find a left Riemann sum. So I'm going to use my left Riemann sums that look like this. How many do I need? 1, 2, 2, 3, 4. I need 4 of them. And when I take a look at the bottoms, I'm going to have a bottom length of 3, 1, 3, and 5. So we've got 3, 1, 3, and 5. And I'm going up the left, which means that I'm using the 80, the 66, the 62, and the 51. The 80, the 66, the 62, and the 51. And we're going to use our calculator to find the areas of that, which, shouldn't be that bad considering they're rectangles. Excuse me. So I'm going to get 3 times 80 plus. It's always nice to write these out because in case you screw something up, at least they can see what you were trying to do. So I always make sure that I have that sort of written out to show. And then I can run it all in the calculator. Plus 66 plus 3 times 62 plus 5 times 5. So that turns out to be 517, which wouldn't make very much sense because if I'm just doing the Riemann sum right here, what I'm doing is I'm adding up degrees Celsius and then times minutes. So this is degrees Celsius minutes. Because down here, this is your minutes and this is your degrees Celsius. And that seems like a very weird kind of unit. But remember, we're looking at the 1 over 12. And this is going to be over our 12 minutes, which is going to create our average temperature. So 517 divided by 12 turns out to be 43 average temperature is equal to 43.083 degrees Celsius from T equals to 0 to T equals to 12 minutes. For part C, it says evaluate H 0 to 12 H prime of T. Okay, so for part C, we're going to go 0 to 12 of H prime of T dt. Well, when we integrate H prime, we get big H at 12 minus big H at 0. And big H at 12, I can see from my table, is going to be 42. And big H at 0 is going to be 80. And we are going to subtract these things. And what we're going to be doing is we're going to be, if I subtract those things, we're going to be getting negative 38 degrees Celsius. So it says, using correct units, explain the meaning of the expression in the context of this problem. This means that the T has cooled by 38 degrees Celsius from T equals to 0 to T equals to 12 minutes. When it says explain your answer, it doesn't mean explain how you got the answer. It means explain what it means in the context of the actual question that you're dealing with. All right, so D, it says now, this is where the graphing calculator kicks in. At time 0, cookies with temperature of 100 degrees Celsius were removed from an oven. The temperature of the cookies at the time is modeled by a differentiable function C, so that C prime of T is equal to this. Using the given models, at time T equals 12, how much cooler is the T than the cookies? So at time T equals to 12, right, the T was 42 degrees Celsius. To find the cookies temperature, what we would have to do is integrate C prime of T from 0 to 12 dt, and then plus its initial temperature. 100 degrees Celsius. Wow, that's pretty hot. Okay, anyway, when I'm going to do this, I'm not going to actually write out the equation. I'm just going to put that equation in my calculator and integrate it. So be really careful when you enter it into the calculator. And so we've got negative 10.285 e to the power of negative 0.225t, negative 0.225t, which is an x for me. And I'm going to integrate that to answer the question. I do believe that this one here, this question was an actual AP exam question, so that you have the ABCD, and this should be like a 15-minute or it's not a bad question, I don't think. My lower limit is 0. My upper limit is 12. And then I'm going to add 100 to it. So I got a negative answer there, right? But if I add 100 to it, it sort of gives the right temperature. So this is going to be 57.361 degrees Celsius. So the question did say, how much cooler is the tea than the cookies? Well, I think we can subtract those and figure out cooler by 15.361 degrees Celsius. Okay, so that is that one. Okay, so yeah.